Okay, evaluating functions is simply plugging in what is the function value when I plug in a certain x value. Now we're going to use correct notation like g of 2. A lot of you are used to seeing f of x or g of x. This is in place of y. That's because when I evaluate g of 2 equals, I'm going to plug in a 2 everywhere there's an x. So negative 2 squared plus 4 times 2 plus 1. And I'm going to plug this into the calculator, and I'm going to get negative 4 plus 8 plus 1, which is going to lead to 5. Okay, so if you were doing an f of x, or if you called it y, you would have your answer of simply y equals 5. Well, that doesn't tell me a whole lot. It tells me y equals 5, but where? For what x? That is why we use the notation g of 2 equals 5. That tells me at x equals 2, my y point is going to equal 5. And I'm talking about the line g. You get a lot more information using function notation than you do when you just change everything to y's. So we're going to evaluate the next two, and I'm going to show you how to do this on the calculator for part of it. Part of it we're going to have to come back and do by hand. Now we're going to be looking at finding g of negative 3. So I'm going to do it in the calculator. So now I'm going to evaluate g of negative 3. So I'm going to go to my y equals, and I'm going to type in my function. Negative x squared plus 4x plus 1. Okay. And I could look at the graph of this if I wanted to. And it's going to be this nice little parabola. And when I want to evaluate g of negative 3, I could simply hit trace, and it brings up some points. I can now type in negative 3, enter. Okay, when x is negative 3, what's y? Y is going to be negative 11. Instantly gives me this. So now I know that g of negative 3 equals negative 11. Okay, now I'm going to do g of x plus 2. Everywhere there's an x in here, I'm plugging in x plus 2. If I have a quantity squared like this, or a quantity raised to anything, or just substituting in general, it is always good to use parentheses. So that way you see exactly where you need to maybe multiply, maybe distribute. So negative parentheses x plus 2 squared plus 4 times x plus 2 plus 1. All right, x plus 2 squared. This is not x squared plus 4. It's negative x plus 2 times x plus 2. Okay, your exponents come before your multiplying. That would be distributing the negative. Order of operations, you've got to satisfy that first. So I multiply all this together. Negative quantity, x squared plus 4x plus 4. Distribute my negative now. Negative x squared plus 4x plus 4. Now I'm going to continue on finishing this, distributing the 4, plus 4x plus 8 plus 1. All I've got left to do is combine like terms. I'm going to relabel it before I write my final answer. G of x plus 2, so it is clearly known what I substituted in, equals negative x squared plus 8x plus 10. I'm going to show you a little different way to do some evaluating. if I go to my y equals, I put this function in, 10 minus 3x squared, and I go back to my home screen. So I go back here, and I want to do some evaluating from here. I can pull it up by its y1, just like I would put f parentheses 2. If I pull up alpha trace, I can select y1, and then I can put parentheses just like I would write y1 of 2. What is that? And I can do the same thing for negative 4. Alpha trace, that gives me my y1. That's essentially what we called f. And parentheses, negative 4. Close, enter, negative 38. So I've got my first two answers done. For the last one, I'm going to have to do by hand. Okay. F of x minus 1 means I'm substituting in. So f of x minus 1 equals 10 minus 3 times x minus 1 squared. Remember, this is a multiplying, not a distributing that square. So it's 10 minus 3 times x minus 1 times x minus 1. 10 minus 3 times x squared minus 2x plus 1. Now I can distribute the 3. 10 minus 3x squared plus 6x. You are distributing that negative with it. And minus 3. And now I've got an answer, f of x minus 1, combining like terms and putting into order, negative 3x squared plus 6x plus 7.